I'm Meenakshi from Rogini College of Engineering and Technology. Today we are going to see the topic Mathematics of Symmetric Key Cryptography. Hope you remember what is symmetric key cryptography. Symmetric key cryptography means for both the encryption and decryption we are using the same key. So what is algebraic structure? So usually the cryptography requires the set of integers and the set of specific operations that are defined for those sets. The combination of the set and the operation that are applied to the elements of the set, both are known as algebraic structure. That is the combination of the set and the operation. What are the operations we are going to apply the elements from the set? So it is known as the algebraic structure. So usually we have three common algebraic structure: groups, rings and fields. We have to know the concepts of modular arithmetic. So what is modular arithmetic means? If a is an integer and n is a positive integer, and we define a modulus n. So what is a modulus n? We all know what is a modulus n. When a is divided by n, what remainder we are getting? So that is called as modulus, and the integer n is called the modulus. Okay. So the properties of modulo operator. The congruences have the following property. If a is congruent to b modulus n, if n is given a minus b. So a is congruent to b modulus n, which implies that b is also congruent to a modulus n. A is congruent to b modulus n and b is congruent to c modulus n, which implies that a is congruent to c modulus n also. Groups, rings and fields, they are the fundamental elements of a branch of mathematics which is called as the abstract algebra, that is the modern algebra. They are the main three components in modern algebra. So what is group? So a group is denoted as G dot. It's a set. Okay, G dot. So it consists of a set of elements with one binary operation. That binary operation is denoted as dot. That associates to each ordered pair of elements in G an element A dot B in G. Okay, so that is every element in the set is associated to A dot B. Okay, that is A, B are the elements in the set, and after applying the binary operation, what happened to that resultant element? So it should satisfy the following axioms. So closure, that is if A and B belong to G, then after applying the binary operation, that is A dot B, that element should also be in the same group G. Associative, A dot B dot C is nothing but A dot B dot C. Identity element, if A is applied with a binary operation with one element E and E is applied with one binary operation A, both the operation should yield the same element, which means that E is the identity element. Okay, for example, the binary operation can be the addition. So if A plus 0, 0 plus A, which gives the result A. So 0 is the addition identity. Okay, inverse element, for an element A into A inverse. Similarly, A inverse into A, which should give the identity element E. Commutative A dot B equal to B dot A. So if all these axioms are satisfied, okay, so then they form the set group. We move on to the next structure, ring. So a ring is sometimes called as R plus star. That is, it is also a set of elements with two binary operation, whereas the group is a set of element with one binary operation, whereas the ring is a set of element with two binary operation called addition and multiplication. And here also we have to follow some axioms, that is all the axioms whatever we have discussed in the previous structure, that is group. Okay, so the rings should satisfy all the addition axioms. Then it should also satisfy the multiplication axioms, that is closure under multiplication. So A and B belong to R, then AB should also in R, that is the set R. Associativity of multiplication, A into BC, AB into C, both should be equal. Distributive laws, A into B plus C is nothing but AB plus AC. A plus B into C, so you can write that as A into C and B into C. Okay, so this is distributive law. So a ring is said to be commutative if it satisfies other additional condition, that is this one, commutative of multiplication, A into B equal to B into A. What is multiplicative identity? So we all know that the multiplicative identity is 1, that is A into 1 equal to 1 into A is equal to A. Okay, no zero divisors. So if AB in the set R and AB equal to 0, then either A equal to 0 or B equal to 0. The next algebraic structure is field. So field is denoted as F plus star. Again, it is also a set of elements with two binary operation called addition and multiplication, and here also we have to follow the axioms, that is the addition axiom and the multiplicative axioms. Other than that, you have to follow one more axiom, M7, that is multiplicative inverse. Okay, for every element A in F except 0, we must have one inverse element, that is A into A inverse equal to A inverse into A. It should give 1. Okay, that is the identity element, multiplication identity element. So with this we are concluding today's topic. Thank you.